Hi everyone, welcome to this video in which we are going to review the functions in C programming language. Um, we are going to learn how to create them, how to use them, and some topics related to variables and functions. We will see how these functions are treated in memory and the pointer to function. Okay, so first of all, a function is a set of statements that perform a task which requires several steps. That is, a function is used to group or associate several statements into a block. That's because all of these statements perform together a common task. So this is why we associate them. Also because we may have a really large program with thousands of statements, one by line, which is difficult to analyze and to correct if any error has arisen. So, for instance, we may group several printf and scanf to do some to handle or the user input. That is, the printf sends messages, so the user will input particular data. Scanf or fgets or whatever input function you have will take that input, and next you are going to store it, organize it, or in any order. Okay, so all of that work can be grouped into a function because it's performing the input and organization of user input data. Okay, and the other part can be the calculations in another different function. In this way, we achieve modularity. That is, we break the program into smaller tasks, and whenever we want to do modifications, we can work on just the parts that we need to change or the parts we need to correct. Uh, we already know the main function. Remember, a function has a name in C language, also the trailing parentheses after the name, and then the curly braces. Within, uh, within the curly braces, we have the body of the function, that is, the group of statements that function accomplish, okay? So remember that this is the body of the function, and a function typically has a name, the parentheses, and the curly braces. To create a function, you have to know about uh, function prototype. Remember that in a particular variable that we create in C, we used two operations, let's say, the declaration and the definition. The declaration is just when you create the variable. So to create the variable, you specify a type and a name, okay? When you define the variable, it's because you did not just create it with a name and type, but you also specify the value. Okay, so the function declaration and definition also has the same some similarities. Okay, let's see what's the how do we declare and define a function. We must specify the return type, then the name, and then within the two parentheses, the arguments or data that is going to receive. So we have in this case two data here. Both of them are integers and separated by comma, and we gave them a name, okay, to each. Um, this is a simple function declaration without declaring the body of the function within, the curly braces. We are not declaring the statements in this case, but just the name and this part without the body of the function. Okay, let's explain in more detail. The return type is the data type that this function is going to return as a result. It's going to do some operations here in the body of the function, but at the end, it may return some value, some result. So this keyword here specifies what's the data type of the result. Okay, so in this case it says integer. Okay, so I can expect an integer as a result. You can also create a return function with return types double, char, void, or pointers to integer or wherever. We use the keyword void whenever we are going to do some process here in the body of the function, but we are not going to return any value as result. Okay, so you know how to use now the how to specify the return type. Okay, then we must specify the function name, which must be a valid name. Remember that we can't use a keyword and um, neither special characters or leading numbers. Okay. Okay. The function definition is when you declare, okay, return type, the name, and within this parenthesis, the mm, the data that is going to be input, or that function is going to receive and will perform operations on. Okay, so in this case I am asking here for integer a and integer b, that is those the two integers, and we have names for each one, a and b. So inside this function I can now just refer to them just as simply a and b, because I already create them here. These arguments are also called parameters or function or formal parameters, which all of that means is that we're creating two integers here and these are their names. Okay, or whatever we can specify double or whatever or type as input. Okay, and then here at the end of this addition, because I am adding a and b, I'm going to return, well, to store the result in C and return C. What is that? I'm going to return the result of integer type using this final keyword return and this variable of the same data type that I specified here, integer. So it is okay. So whenever I am not using any, I'm not going to return any value. Remember that we use the keyword void, but I must also um, specify return followed by nothing but a semicolon. So return just a semicolon because it's not going to return anything. Or actually, if it is void, you can also omit the result because only when you specify a different type than void, you need to use the return and variable of the same data type. So now you know how to declare a function, how to define it, and whenever you define it, it's already created. Okay, so now it's usable. So you just create the function, and then to use them, you will have to specify the name, just like in here. And if you specified that it had some arguments as input, you will have to input the same number and type of arguments. Here we have integers and there are two. So we are using the function by specifying its name and the arguments that it needs. If I'm missing any of these arguments or I'm specifying any argument of different data type, it will throw error. So it says int and int. So I will have to use integer and integer, okay? And the total number is 2. This is known as function call. That is when I already created and now I am using that function. So this is a function call. I'm calling add and specifying these parameters, okay, or arguments, 3 and 2. They are going to be added, okay. And since the result is of integer type, what I expect here is that this expression add and within this parenthesis the operands uh, to be equivalent to a result of a type int. So because this function is returning a value, I must collect that result into a variable of the same type integer, like in here, this r, okay? So I will be able to use it later in this printf that is asking for an integer, and I'm going to print here the result r, okay? Uh, I could also have made use of, instead of creating this integer here, this integer variable that stores the integer result, I could have just used the add parentheses 3 and 2 um, here instead of the r, okay? So it depends on your usage. However, remember that the result, if we are not going to perform any operation with it in the current type or current time or immediately, we must collect the result in the function call, okay, to have it available. So enough talking, let's do an example code. Okay, now let's continue with um, a sample code, an example. So let me, okay, I'm going to create here two integers. One is 10, another is 20, with the names x and y, okay? I'm going to create an addition function, okay? So let's call it, well, it's going to receive two integers, and the result would be an integer, okay? So since the result is an integer, I'm going to use the keyword int as return type. I'm going to call it add, whatever name that I want, as long as it is a valid name. I'm going to ask for two integers as input, so specify int and int, okay? And in the body of the function, I'm going to use that int a and int b, and I'm going to create a third integer called c. So c, it's going to be we're going to add a and b and store the result back in c, okay, just like in the example. And remember, I have to return, use the return keyword, and return the value of c, which is the result of the addition, okay. Now remember that I could use here this thing. Let's say this is the function calls. I mean, I already defined the function, okay? I created the entire function with its parameters, its return type, and its function body, the operations, okay? Now remember that to use them, I must do a function call. A function call is done by specifying the name exactly, which is add. We don't need the int because it's already recognized here. And then pass the parameters or the arguments required, which in this case are two integers. So let's say x and y, which are 20 and 10, okay? Now have a look here. It says printf, it's expecting an integer, and guess what? Just as I told you, it returns an integer, no matter that it says add or whatever, because it's going to return or convert into a single value of result, which is integer. So let's hit run. Yeah, there we have 30, okay? However, sometimes we need to do intermediate steps or I don't know, some additional functions. So what we do is, since it's going to return an integer type, if I want to store the result temporarily, I must define um, a variable of the same type. That is, it returns an integer, which is the addition of a and b. So I need to create an integer, and let's say just t. So I'm going to collect the result of addition of x and y, which are two integers here. I'm going to collect the result, which is 30, inside t, okay? This is useful. And now I'm going to print the result by using the results stored here in the variable integer t. Okay, so you can do both. You can use it directly, or you can store it in a variable of the same data type, or the return type, okay, of your function. Something else that you can do is, to avoid any pitfalls or errors, is defining the function inside another function. This will show no error because it is super weird sometimes. But if you go to a strict compiler, as you can see here, I created a function inside the main function. If I try to compile it, it will show error. Function definition is not allowed here before blah blah blah. Okay. However, if I place it outside, Control S, to save changes, it will do the operation normally. Sorry, okay. Well, sorry. Yeah, so you can define a function inside another function. You can call it, okay? I mean, once it is created, I can call it just like I did here, add with those parameters, okay? But I can create it inside. Also, if I were to place this function in another place, let's say um, just before the body of main, it will throw an error. Guess what? Okay, this is very permissive, but it is if I compile this in the compiler, it will show an error. So the error here is because, or the warning is because I am using the function add, but as if you remember, I must define in C all the functions or the variables that I'm going to use, because in this point I'm going to use in the line 13 add, but I haven't created already or define it. So it's going to get to this point and I'm going to do add. Okay, yeah, but what's add? I haven't told the compiler before in the earlier lines in the okay. So what we do now? Okay, here is I can place it in the beginning just like before, or since a function can have several lines and will be I don't know, will be like too much. These lines will be really full of letters and you can concentrate or focus on the main function. So you leave these functions, the body of the functions entirely um, after the main function. But to avoid this error, you must do the declaration, okay? Just the declaration here. This is the function prototype, which means that in this point in line 13, it will now know what's add because I already told him from the beginning and prior to mention the function add here. I'm doing the function call here, but I already told it, okay, I have a function which is named add that returns a type integer as a result and will take two integers. Okay, so I use the function prototype here and the function definition uh, just after the main function. Okay, and then we will have no errors or warnings. Okay, now let's implement a function to calculate the area of a circle. Remember the formula is radius to the power of 2 multiplied by p. For this purpose, since we need to raise to the power of 2, we will need a function of the standard library called pow. Okay? Pow, which means power. It is defined in the library math.h, so we will need to include math.h. So include math.h. Then use this define directive to create a macro for p. Okay, this is the value 3.1416. Okay, Now we're ready. Let's create a double data type. Let's call it R for radius, and let's give it a value of 3. Remember that doubles must be written in the notation of with decimal points. And another double variable that we hold the result, which must be a double. So since the result is double, it means that our function is going to return double as a result, because we will need fractional parts, okay, decimal part. So the result a, which is area, is equal to circle A, which means circle area, and this circle area function is going to receive the argument of uh, of uh, radius, which is in this case r, whose value is 3.0. Okay. Okay, this is the result. The format specifier in this case is LF for long float, and printf and a, because a is the integer that holds the result of type integer that circle A will return when we passed the value of r, okay, of radius. Now I have to define the function, okay? Remember that since I collected the result of circle r in a double type, the result, that is the return type, will have to be double. And the name I also defined it already here as circles A, okay? And remember, in arguments I will have to collect this r, okay? So remember that r is of type double, so write double r, or you can change the name wherever, but however you know that it's the radius, okay? Here we create another double variable. Let's call it a again, in uppercase, and it's going to be equal to r, but first we have to raise r to the power of 2. So we use this function power. The first argument that we're going to use is r, then comma, and then the power, which we are going to raise that value of r, which is 2 in this case, power of 2. So it is radius to the power of 2. And now we just put here the multiplication by pi, okay? And then we must return a, sorry, which is the result, because here we established that the return type was double, okay? So r to the power of 2 multiplied by p should be the area. So let's first test with value of 1.0 to the power of 2, it will be 1, and multiplied by p should be the same value of p. Let's return here. Okay, I guess it's okay. Yeah. Now let's back to the original radius that we wanted, because we already checked that it's right. Okay. Actually, we could say here the area is colon space and okay. Okay, now let's do an example for a function with no return type. That is, the return type is going to be void, and We are giving it a name. I will use this print line, prints line, and it will take no arguments either. Okay, so let's start. I'm going to print the sole purpose of this function is going to be print as continuous line. Okay, so the character will be this underscore, but I will have to repeat this a number of times. Actually, let's use a for loop, and it will print up to 20. For remember the indentation here, and at the end it will print a new line. You will go to the next line once 20 of these underscores are printed. Okay, so now that it's created, remember it returns no uh, result or variable, and it will take no argument. I can leave this parenthesis blank or use the keyword void. It doesn't matter. And now I can call the function. So make the function call, specifying the name of the function to a parenthesis with no parameters or arguments, and we're ready to go. So I will print hello and then this line. Here we are. Also, I could have defined, if I wanted, um, to receive some arguments. So I will place here int n. So depending on how of this number, we are going to print the same number of underscores. So let's replace this I with the n, because our now the repetition of this loop depends on the number that the user specifies for the underscore. So prints line, and have a look what happens here. Since I executed but I gave it no arguments, it will throw an error. So I'm just let's say that I want 10 lines. Okay, try 10 underscores. So yes, okay, let's hit run. It just printed 10. Let's do a test with, yeah, of course I didn't change this thing here. So now you know what, I made a mistake. I should have placed here I, same I. As long as I is less than n, we will keep incrementing I. Sorry, I made that mistake. So let's hit run. If I pass the argument now to be just 10 as the maximum number, it will be shorter. And if I press and if I pass the value of, let's say, 100, let's see what happens. This is rather weird. Let's stop the program and let's say just 50. Let's hit run. Okay. Okay, now let's talk about the concept of call by value and call by reference. Whenever we call a function, we pass it some arguments. So there are two ways in which we can pass those arguments. We can pass them by value or by reference. Let's start with the call by value. Whenever you pass values um, of variables by value to a function, it's because you are copying the actual values of that variables into the variables inside that function. It means, remember that we call these two variables here formal parameters. So whenever I pass the argument 12 and 15, it will create a copy in this integer a and integer b, which live inside this function, named function, uh, and will store copies of these values that I uh, pass to that function. So we have 12 and 15, but these variables are different variables than these ones outside the function. Okay, so we basically are making copies inside the internal variables of the function, which are called formal parameters. Okay, which has two integers named a and b. So if I do this assignment, which will write the value of 20 inside a, it will change the value to 20, but it will change the value of this inner variable named a, not the original that is outside this function. Okay, so we basically are making copies of the values of the arguments. Okay, received. Most of the times it does its job because we only need to have the numeric values or wherever value that they have without affecting the original. Okay. Um, the call by reference of a function is when we pass reference or the address of the original values. That is, instead of copying the value of 12 inside our inner variable here, we are doing two pointer variables to point to the original values. So whenever I do this uh, change, whenever I do this modification of the value of a to be 20, now I'm not going to store the value of 20 inside an inner variable, but I am going to store the value of 20 in the actual um, variable that I passed here. So whenever we pass arguments by reference, we are not referring to the value that it holds, but to the actual address that it has. So if we change the value, we will actually overwrite a new value in the original variable that is outside this function, as you can see here. Thus, reference or pointers are pointing to variables outside the function, while in call by value we were working on inner variables. Okay, so remember this is the reference operator because we need to access the value inside this reference, not the address. Okay. uh, okay, let's see a concrete example of this. This is a function named swap, whose purpose is to swap the values of these two integers. So we're going to swap this 12 with the value of 15 and this 15 with the value of 12. We'll start making a call by value uh, to the swap function. We create a third integer named c inside. Okay, so we have int a, b, and int c. Then we do the copies of the original values, just the values, so 12, 15, and then we store the value of 15 here safely in the C integer and start doing the swapping. So we pass the value of 12 that was formerly 15, and now this value that 15 that we saved previously is passed to the former value of 12. So we have now value of 15 and 12. Okay, but whenever we go out of this function, because it was all it has finished its task, if we print the values of a and b, we will find that there are still 12 and 15 just like before, and it is because we were making those changes with clones or copies of the original values inside this function. So these variables that we were managing um, are inside this function, but are not the real variables that are outside the function, okay? So it won't work for changing the actual value, okay? If we wanted to change the actual value in these operations, the operations inside the function are meant to affect the original values, we will do a call by reference of that function. So in this case, we are creating a pointer named A, and other pointer to integer named B, okay? So both are pointers to integers, to the original values A and B outside the function, okay? So we create another integer C to store temporarily one of those values, preventing the loss of any of them. So we load the value of A, which is 12. Remember that we are dereferencing because we don't have a normal integer but a pointer to integer. So the pointer gives us the address, but we need the value in that address. That's why we use the reference operator. So we take the value of A and store it in C. So C is an integer which is inside the function, okay? But A and B are outside. So we place the value here 12. Then we store the value of B, which is 15, in the value of A. So we will have here 12 replaced by 15, and here the older value of 15. Okay, now we have to pass this value of 12 back in B, okay? That's what we do here. So now we have swapped successfully these two integers. So the final result will be this one. So we completed our task successfully. So whenever you want your function to alter or change the value, the actual value of the arguments that you pass, you will use reference to that type of variable, okay? In this case, pointer to integer. Okay, now let's do a demo with this concept of call by reference and call by value. So, okay, it's of return type void. Let's call it swap. Let's define integer A, integer B, and then the body of the function is integer C. Then, sorry, we will copy int C equals to A, and now we change the value of A to B, and the value of B to C, which was the former value of A. So that's it. We can place here the return statement, or we can leave it without the return statement. It means it's the finish of the function, okay? And if we call it a value here, swap, and pass the values of A and B, they will make changes just in the variables inside the function, which are different from that values int and a that are defined both inside main, okay, which are outside of this swap function. So we have the same result. A is still 12 and B is still 15. So let's say here A colon and B colon, okay. So now we are going to implement the call by reference to make actual changes into the original variable. So we use pointer to integers, but now we have to correct here because remember A is now pointed to integer, so to get the value inside A, I will have to dereference it. So we use asterisk, then I have to dereference B because I am taking the value of B, and we have to dereference also here A, and finally the reference in B, and see it's plain integer, so we won't have any trouble here. I'm having some errors. It's doing something. So yeah, of course, because I am passing A and B as pointer to integers, I will need to use the address operator, okay, in the function call. So remember that a pointer is meant to store an address. So if I pass here A, just A, I will be passing just the value of 12. But if I use the ampersand operator, I will pass the address that is expected to for a pointer. So let's see. Okay, no errors. And as you can see, A was changed to 15, which was the value of B, and vice versa. A was changed to B was changed to 12, which was the former value of A. Okay, now let's talk about an important feature of variables, which is the scope. The scope is uh, the visibility within a program of a variable and its lifetime in memory. Uh, we have two main uh, types of scope for a variable. We can have a global variable. It means that it is accessible from anywhere in the program and that it will be stored in memory uh, during the whole program. It won't be erased at some time, just only when the program terminates, okay? So for instance, we have here an integer x that it's first of all outside all of the functions, okay? So a global variable is the one that is created or defined outside all of the functions. So therefore it would be visible from any function. As you can see, we are using it here, assigning the value of 7. In other, we are using the value of x to add it 4. And as you can see, it's available for all the functions to use. Also, one other characteristic is that if I hadn't defined the value of 3 for x, just leave this with a non-specific value, it will be initialized by default to 0, okay? Uh, these are the main features of a global variable. Now, local variable is the one that is defined inside a function. It means that it won't be accessible to the rest of functions. For instance, if I try to use it or modify it from int main, it will throw an error because it is only usable here, okay? Also, as far as for the lifetime, um, a local variable will not remain in existence during the whole program. Remember that when we call a function, we do some operations and then we end that function, we terminate that process. Whenever we terminate that process, all the functions, all the variables that this function created will be erased from memory. So this variable will borrow some space in memory while it is being executed, and whenever it finishes execution, it will um, give that block of memory back, and therefore the system will erase uh, that block of memory. That is why this variable is temporary and disappears with the value that it stores, okay? Also, this variable, whenever created, since it is borrowing a block of memory that is being reused and reused, Whenever we do not specify a value, like in here, the value by default that it will have is a value. That is some random value that was left in that memory by the previous process, okay? So it's not initialized by 0, it has a limited lifetime program, and it is erased and not accessible outside the function, okay? And it's not visible to the rest of the functions. To resolve that complications from a local variable, and that is by using the static keyword before the definition or declaration of your variable. For instance, if I need this local variable in C because it's inside this function to remain upon function termination, I will use the word static in C. Then it will allow me to write this variable not in that temporary block of memory, but it's going to be uh, stored in the same block of memory of the global variables. Remember that the global variable will exist for the whole duration of your program, okay? So it will be written in the same block of memory, avoiding this variable and its value to be erased upon function termination, okay? So, however, there's an exception. Although I will keep the values in every function call whenever it finishes execution, the problem is that this variable is still visible just inside this function. So whenever I call it, I can use the value. But if I wanted to use them outside the function, it still behaves like a local variable. It's not accessible. So I could use them inside this function, this wherever I use this function call, or use a pointer to point to this variable that anyway is inside that the same memory block here. But you know how it is. Since it's not accessible, I will try to use pointer to access um, that address that is conditioned with the duration of this function. Okay, now I'll explain a little bit more about what I just told you about local variables and global variables by understanding what's the memory layout for a program. Okay, so basically we have um, large, well, some block of memory that is granted by our system whenever we initialize our program. Um, and we have these different sectors of memory because we are going to use them for different purposes. So remember that we compile our program and it is translated to binary code. So this binary equivalent of this source code is um, stored here in this section. This is a read-only section because we don't want to make changes to any of the instructions there, okay? The variables that we define as global or local, but with the static feature, will be stored in the next section of the memory, okay? And they will be available to the end till the end of the program, okay? Then we have another segment or pool of that block of memory for our program that is called stack, okay? And the other one is heap. Um, in this stack is where the temporary operations take place. That is, just as I told you, whenever we call a function, it will be executed, and when it finishes, it will give the memory uh, back to the system. That is, it will create wherever it needs, like these integers here and the values, and do the operation of, in this case, addition. But whenever it finishes, it will be erased from that part of memory, okay? So this is the stack, which is the part that is reused whenever you enter a function and whenever you leave the function, with the when you terminate the function call, you go back to the rest of your main or wherever. So anything that is performed temporarily will be stored here, executed, and then it will be erased. In the heap, we can create some other variables, um, or store some other data that we hadn't defined previously here, which is known as dynamic memory allocation. We'll see that topic later. And um, okay, let's do for now an example of how will be the execution of this program. Okay, this is a global variable, as you can see here, x equal to 3. Then we have a function and the main function, and we do a call to the add function here with an argument. Okay, then it will do this operation and then will print the result, and we will terminate this program. Okay, so let's see how it goes. First of all, as you can see, since it is a global variable, it will be created in the static global piece of memory block. Okay, then we are going to the main function. Remember that we always start execution at the main function. We created the global variable, then straight ahead to main function, and now we change the value of x to 7. Let's see, main started executing here in this temporary uh, memory, storing memory, and it changed to 7 because main says so here. Okay, this is the operation. Then we are going to call the function add with this argument. So main will create another, as I was telling you, a temporary variable c to store the result, and it's calling the add function. Remember that this add will be executed temporarily, so it will be the memory will be allocated here in stack, and then what happens? Add creates a temporary variable that it's here. Okay, we are now here in this function, so we are creating an integer a, and it's equal to 3. Why? Because we passed this in the function call. So this argument here is the ones that goes inside here integer a, and then we create an integer y that is here. Okay, and we are going to perform the addition of x plus a. Remember that a is now 3, which is this argument, so 3 plus x. The value of x was 7. Okay, so now the result is int y equal to 10. Okay, and return y. That means that add will terminate, and remember that everything else will be erased. These integers that were created, we are returning just the resulting value 10. As you can see, it's being returned, this value, and it will be stored in int c. Okay, that was created inside main, so this belongs to main, this int c. Int c equals to 10, and then where we are now. Okay, this part is done, and now we are calling printf. Okay, and printf will print this value in C that was passed here, and okay, return 0. So the main will terminate and will pass the number 0 or success to the system. So it will be erased now from stack and our program finishes. Okay, now in this example I'll show you how to return more than one value from a function. This is not the only way, but I'll tell you about. Let's create a function that will return int, and let's call it fill array. Fill array. Okay. It's not going to ask for any argument, so we can leave the parentheses blank or write the keyword void. I'll leave it blank. Where else? I'm going to create a integer array num of 10 positions. Okay, now I'm going to fill every position with numbers. Particularly, I'm going to go in a loop, and for every position that's going to be incremented here from e equal to 0 up to less than 10, which is 9, so 0 to 9, 0 position up to ninth position, and each of them is going to be filled with the value of e. So position 0 will start the value of 0 because at that time e is equal to 0. Now position 1 is going to be we'll store the value of e, which is currently e, and so on and so forth up to 9. And at the end, whenever I finish here, remember that we have to use the indentation, or we can use the brackets. This is how I ensure that it is inside the for. Okay, and outside, whenever I'm finished, I'm going to return num. Okay, I'm going to return num. However, there will be an error because I am trying to return a local variable. Remember with what I just told you before, that local variables exist only inside the function and during the execution of that function. So if I use this, let's say I make a function call to fill array, and it is supposed to return an integer value. So I create here an integer variable to collect that value of integer, and okay, and now I try to print the result. It will be an error because this all of this information, all of these values will be wiped whenever the function terminates. So I need a strategy to make this array available. Remember that I told you that with static word we can make this to last no matter that the function terminates. So I'm creating this array in an area that is not that won't be erased, not the stack, but you know the other block of static and global variables. So okay, it will remain. What's the problem? That no matter that it is that it will remain in existence, because I still have one problem, and it is that it is a local variable. So anyways, no matter that it is not erased, it won't be accessible outside the function. It is so in main I can call it because it is inside this fill array. So the way to do that is to use a pointer, so that a pointer will point to that position in memory, so I can use it. Okay, so let's create, and I will need to modify the return type. So I'm not going to return an integer because first of all it's a bunch of integers, 10 integers from 0 to 9 in this array. So I'm going to use the pointer to integer, as you can see here. So pointer to integer is the return type, and now I'm going to I don't have to modify this thing. Why not? Because the num, remember that is the number of this array, and remember that an array is a pointer to a block of contiguous memory with a common data type. In this case, it is a pointer to the beginning of the array in memory that stores integers one after another. Okay, so I don't need to modify here something because it is already treated as a pointer because it is an array. Okay, so now I can't collect the result in a simple normal integer. Why not? Because it is a pointer to integer. So I modify here also pointer to integer, uh, whose name is C, will collect that pointer to integer. That is, will collect the address of the first element of the array num. Okay, now we're good to go. But to visualize it, I will need, to display it, I will need to do another loop. This is the default way of displaying an array by going through all of the positions one by one. Remember the indentation, or you can just simply use the curly braces. Make sure that you have an opening and closing curly braces to distinguish what is inside your for that's going to be repeated. So let's print remember that this C is a pointer to the first position of num. So I cannot use the name num because it is a local variable there. Okay, so I will need to refer to this num array using the pointer C. So I will have to C, which is the first position of the array, um, and I'm going to add the value of I each time. First of all, is C plus 0 because it starts in 0, so it means that it's the first position. Now, whenever it is incremented to e equal to 1, then it will be C plus 1, but that means the position 0 plus 1 position, so the second position. Okay, so again and again, and we'll print the result. But remember that when we want to access the value inside a pointer, we have to dereference it. So that's why I dereference the entire address here. Let's start with the address 0 plus 1 plus 2 plus up to 9 to the ninth position or the 10th position. Okay, so I say that num EF position is equal to, let's see if I can make it to run. Okay, where's the problem? 21 printf. Oh yeah, the comma. Let's see. Okay, I just missed to place a new line. As you can see, you say num e start from 0 up to 9, which is was filled in the beginning. So remember, we can use static to give a lifetime during the whole program, but to make it accessible, we need to use a pointer if we want to go inside this function and recover that variable. Okay. Okay, now I'm going to show you a very important concept that is known as uh, pointer to function, a function pointer. So we have here two integers, and we are going to create two different functions. Uh, each function will return integer as a result. The return type is integer, and let's define add. So let's take two integers, int a, int b, and let's define the body of the function. We are going to create int c, which is the addition of a and b, and return, as we mentioned here, integer. It's going to be c. Okay, now let's do another function with return type integer, mult for multiplication, and it takes also two integers, int a and b, and the operation is okay, let's define int c, which is going to be uh, uh, the multiplication of a multiplied by b, and return also c. Okay, we are done here. Now I'm going to create a pointer to function. Let's use it here inside main. So the syntax is for a pointer to function is first the return type, in this case int, okay? Then a parenthesis. Within this parenthesis you will use the this asterisk, meaning pointer, and we will name our pointer. In this case the name is p, and inside this parenthesis asterisk p means that it is a pointer to function, okay? It is also because if we had on this parenthesis, this pointer is going to be taken like a pointer to integer, and it isn't the case. So that's why we use this parenthesis. And then you will have to define in the second parenthesis the arguments that it's going to take. So whenever we create a pointer to function, we will need to match the same return type and same arguments. That is the same function prototype. In this case, the function prototype, remember that is return type, a name, and the two arguments, or okay, or the whatever arguments that it will request. So return type must be integer, also integer, and we will have in the arguments to place two integers also. Okay, so integer, integer. Um, okay. Uh, Okay, that's it. It has to have the same prototype, that is the same return type and the same arguments, type number and type of arguments in order to be usable. If I had defined this function pointer just like this, it will not match the same exact prototype because we have just only one integer, okay, as argument. So we need both. Two integers, okay? No matter the name. To be honest, I can say here x or wherever. Okay. Now, how do we pass the address of a function to this pointer of function? Now, from now on, I can call it p and pass the address of the function. So let's say I want p to be a pointer to the function add, okay? I can use it just with the function name. Let's see if I got any errors. I don't have any errors here, okay? But I can omit this address ampersand operator because it already knows that it's a pointer function. So wherever I write here will have to be the name of any of the defined functions, which is compatible. That has the same return type and number and type of arguments. So um, let's say that it's add, and let's use printf. Okay, printf. Then we're going to print the result. The result is colon and an integer. That's going to be returned by, in this case, let's place here p because it is the function. Just suppose that since I initialize it with the add, now this pointer it's pointing to add. So this is the equivalent to say that add and the two arguments are going to be a and b, okay? I don't know if I have to reference it. Let's check. Oh no, okay, wasn't needed. As you can see here, I initialize this pointer to function with the function add. So whenever I call this p as a function, it is performing the function add. uh, upon these two arguments, a and b. So as you can see, 20 plus 10 is equal to 30, so it is okay. Now let's replace this with mult, and it should be a different number. Okay, 2000. Yes, we're okay.